Okay, guys, so this lesson is about two things. It's about writing equations from the graph, and it's by finding where the graphs cross the pole. Okay, so we're going to do both of those things for each of these. Okay, so the first thing you have to know is the equation is going to be A and then either plus or minus, not both, B sine theta. Okay, or it's going to be A plus or minus B cosine theta, depending on the symmetry. And of course, A and B can be the same if it's a cardioid, but they're different if it's a lemmason. Okay, all right, so this is not super hard if you follow this one really couple important rules that I'm going to give you. Okay, so the first thing is when you look at this, there's a couple things you guys should notice. Okay, the first is that this is the line of symmetry right here. Okay, and even if you totally forget which shape has the line of symmetry there, you can just say, okay, what trig value, sine or cosine, has the same value here as it does here? Okay, and of course it can't be sine because sine is positive here and negative here, so it has to be cosine. So anytime you have symmetry to the x-axis, you know the graph is going to be a cosine graph. Okay. The next thing I want you guys to notice is that almost the entire polar graph is to the left of the axis, which means it is going to have a negative sign in here. Okay, so it's going to be cosine, it's going to be negative. Okay, all right, so then when you go to write it, you write, let me use this one. Okay, you write r equals as your first thing. Okay, and then this is really important. Okay, the a value right here, the one that comes first, always has 2 points on this axis symmetrical. So this point right here is the a value. This point right here is the a value. That's always going to be the case because that's where cosine is 0. So if you plug in pi over 2, this part goes away and you just get a. If you plug in 3 pi over 2, this part goes away and you just get a. So in this problem, the a value is 2. Okay. We know it's minus because we already figured that out. We know it's cosine. So the only thing we have to figure out is what number goes right there in front of cosine. Okay, so here's the rule. Okay, you count out the biggest value. So 1, 2, 3, 4, 5. So this goes out to 5. The addition of these two numbers without the sign, so just like with ignoring the negative, the addition of these two numbers has to add up to the biggest, okay? So the only number this could possibly be is 3 because 2 plus 3 is 5. And then a nice little check, I just always check this to make sure, is I subtract them, 2 minus 3, and you get negative 1. So this loop right here has a radius of 1, and you know it's negative because it's an inner loop, and only inner loops are only created if the r is negative. So now I know that this is definitely right. So this is a lemmason with an inner loop. This number is bigger than this one, as it should be. This is negative, this is cosine. Okay, so that's my equation. All right, to figure out where it crosses the pole, you might just figure, oh, it crosses right there at 0, 0. Remember, that's not necessarily true because no matter what the angle is, if the r is 0, it's going to look like it's at 0, 0, even though it almost never is. Okay, so to find where it crosses the pole, so where does it cross the pole? Okay, the only thing that this has in common is that r equals 0. So every single time I say to you, where does something cross the pole? You say, oh, that means r is 0. So you do 0 equals 2 minus 3 cosine theta. Okay, and then you just solve. So you subtract 2, divide by negative 3. So you get 2/3. Okay, now sometimes this is going to be like a half or root 3 over 2 like a unit circle angle, but of course 2/3 is not. So the only proper way to solve this is to do cosine inverse 2/3. And remember, I know this is tricky, but this is an equation, okay? We're going to solve, sorry, I didn't write this. We're going to solve all of our equations between 0 and 2 pi, okay? This is not an inverse problem, so this does not have a domain restriction. There's not like one answer in a certain quadrant. You're supposed to find me every angle on the unit circle between 0 and 2 pi that has a cosine of 2/3, okay? When you type this into your calculator, make sure you're in radian mode. And the calculator, of course, it will give you one answer. So it gives you 0.841, okay? So that is a first quadrant answer, maybe about here. And then you guys have to know that there's another one right there, okay? And that is 2 pi minus 0.841, okay? So the other answer is 5.442. Okay, and I do want you guys to write these as coordinates. So the proper answer to this problem is it crosses the pole at r theta, r theta. Okay, so it crosses the pole twice. If you did a table and you got this perfectly, you wouldn't get these values because they're not in the unit circle, but that's where they do cross, okay? And it crosses twice because it loops around like this and then comes back and loops around again, okay? All right, so the next problem is also a limacon. We know it's not a cardioid because there's no point at 0, okay? We know it's a limacon without an inner loop, okay? I always do this part first. We know that this is the line of symmetry, and the only trig function that would have the same point here and here would be sine, because cosine is negative here and positive here, so we know this is not a cosine graph. So this is definitely a sine graph. Sorry, that's a little high, but it's okay. All right, we also know that almost the entire limacon is in the positive. So this part is bigger than this little part right here, okay, which means that this graph is going to have a plus sign, okay? It's wherever there's more, okay? All right, so this is what we know so far, okay? We know it's r equals, okay? And then we know it's sine, we know it's plus, and remember to find that a value, it's really easy. So for sine, it's this. There's two symmetrical points always on the axis that's not the axis of symmetry, and those are always going to be the a value. So it's 1, 2, 3, 4, 5. So in this problem, the r value is 5, okay? All right, we know it's plus, we already talked about that, and we know that it's sine. So the only thing you have left to find is the number in front of sine, okay? And remember, you do it the same way you did number 1. You just count the biggest one. So this is 1, 2, 3, 4, 5, 6, 7, 8. So the biggest radius of this problem is 8, which means that these two have to add up to 8. So the only possible number there could be is a 3, okay? And as a double check, I want you to subtract these. 5 minus 3 gets you 2, and that should be the radius of like where that little dip is right there, the smallest value, okay? It's not negative this time because there's no inner loop. Okay, all right, and then you can, when I say where does it cross the pole, you can see on the graph that it doesn't cross the pole, but I want to show you mathematically why. So if you do 0 equals this, okay, and you subtract, you get this. Okay, and then you guys should all know that sine's not allowed to be -5/3. Remember, sine only stays between -1 and 1. So if you accidentally tried to figure out where this crossed the pole, you would just have no solution. So it doesn't cross the pole. It doesn't cross the pole. It's also a really good way to remember which ones have inner loops. If I give you this problem and I said, does this have an inner loop? And you just really can't remember, okay, you could solve it. If it doesn't cross the pole, there's no way it has an inner loop. If it does cross the pole, then it does have an inner loop, okay? All right, next two problems. Okay, so we've done, the next one is obviously a cardioid, and we've done these before, but it's always good to like mix things up, okay? So this one, okay, so this one, the line of symmetry is here, okay, which makes it a cosine graph, okay? The majority of the cosine graph is in the positive to the right of the axis, okay? So we know it's a plus, we know it's cosine, and remember this is going to be our a value. Okay, so that's pretty much everything we need. Okay, so we have r equals, okay, the a value is 2, we know it's plus, and then there's two ways to do this. Like, if it's a cardioid, the numbers are going to be the same, or you could just treat it like a limacon. This was 4, so those have to add up to 4. Cosine theta, when you subtract 2 and 2, you get 0, which is why it goes back to the pole, okay? All right, cardioids only cross the pole once. Limacons with inner loops cross it twice, okay? So when I figure out where this crosses the pole, we're only going to get one answer, okay? So you go like this, you subtract. -2 divided by 2 is -1. Sorry, okay? And then you do, this one you do not need a calculator for. You guys know where cosine equals -1, that's at pi. So in this problem, theta equals pi, which means it crosses the pole at 0 pi. Okay. Remember, you can cross the pole at 0, 0. That definitely is possible, but it doesn't happen every time. So don't tell me that this point's 0, 0 just because it's like, you know, like a coordinate on XY plane would be 0, 0. Okay? All right, so let me just write that. That's crosses the pole. Crosses the pole. Okay, so we have one more. And remember, you guys can do whatever you want on these videos. So, you know, if I'm doing too many examples, you can just do them yourselves and then just make sure your answers are right by checking them at the end, okay? So this is a sine, okay? The majority of the sine graph is in the negatives. We know it's a limacon with an inner loop, and we know that this is the A value. Okay, and let's just go ahead and do this part too. 1, 2, 3, 4, 5, 6, 7, 8, 9. This goes to 9. So our two numbers have to add up to 9, okay? All right, so we do R equals, A is, what, 3? We know it's minus. We know they have to add up to 9, so the only possible number is a 6. We know it's sine. And then as an extra check, please just do 3 minus 6. You get negative 3, which means this loop right here should have a radius of 3, and it's negative because it's an inner loop. So then it's almost impossible to get these wrong if you check that part, okay? All right, to find out where it crosses the pole, we know it's going to cross twice because all limacons with inner loops cross twice. Okay, this one, when you subtract 3 and divide by negative 6, you get positive 1/2. And lucky for us, we don't have to break our calculator out for this because we already know that. Where does sine equal 1/2? Between 0 and 2 pi. When theta equals pi over 6, and 5 pi over 6. So this crosses the pole at 0 pi over 6. 0, 5 pi over 6. Can you guys still see that? Ooh, yeah. So this is where it crosses the pole. All right, group. So this is cool practice, right? We get to practice our trig solving and our polar together. Love it. All right, until next time, guys. Bye.